Hello, let's go through this problem. Um, it's a contingency table problem in a survey of 100 insurance claims. 40 are fire, 16 of those are fraudulent. Also, there are a total of 40 fraudulent claims. Let's just input the data that we have. Let's see, in a survey of a total of 100, so 100 is your total. That goes here. 40 are fire claims, total fire claims. 16 of those are fraudulent. So we have fire claims. There are 40. 16 of those are fraudulent. And the way you find this value is 40 minus 16 is 24. We can fill in the missing values as well. Over here, this one's going to be 60. That's all we know so far. Also there are a total of 40 fraudulent claims. So fraudulent claims, there are 40. Notice what's going on here. These are the same values. Awesome. Normally this doesn't happen, but it does happen at times. When these are the same values, this means something. And they're probably going to ask a question referring to this. 24 plus something is 60. This is 36. And 40 plus something is 6. That's 60. Okay, from this I can calculate different probabilities, but it looks like these are going to be the same. Interesting. Let's look back at the problem. It says, what proportion of the fire claims are fraudulent? Fraudulent, 40 out of 100. Awesome. Are the events a claim is fraudulent and a claim is a fire claim independent? Fraudulent, fire claim. Are they independent? Well, to determine independence, you gotta do the test for independence, and that's simply the probability of fraudulent given fire and the probability of fire given fraudulent. And these should be equal if it's independent. Most of the time, in a table, in a contingency table, when you have two events, most of the time the events are dependent, but it looked like in this case, since you have some values that are exactly the same, you're going to have two different independent samples events that's within your table. So let's look and see. Let's do the calculation to see. You can kind of visually see that, but let's do the calculation. The probability of fraud given fire. Well, probability of fraud given fire is 16 out of 40. What's the probability of fire given fraud? We're going this way. Fire given fraud, same thing. That simply means that these two events are independent of each other, which means one is not connected to another. That means one doesn't affect the other at all. So the answer to this question, are the events a claim is fraudulent and a claim is fire independent? Your answer is yes, they are independent. And it says use your probability of part B to prove your answer. Well, part B kind of goes along with what we just did because we just did part B again. So that's it for that particular problem.